All right, let's do some transformations. This is page 2 of Unit 4. The first thing you need to remember is that if I'm trying to do a composite transformation from A to A double prime, so I'm just going to think of it in terms of this one point, that's right here. You could do it two ways. You could first rotate it twice this angle. So I'm going to say rotate A about the intersection point right here 120 degrees, and you get the 120 degrees by doubling this. So this one would be rotate from A to A double prime. It's the same deal. That would be up here. That's going to be a right angle because it's twice 45. The first way is you could do a rotation of twice the angle formed, or you could also do a reflection. In the first line I would reflect over as K, and then reflect A prime in line M. So you reflect in line K and you reflect in line M. So it's either a double reflection, which is the same as a rotation. I could do the same thing here. It's either a rotation of 90, or I would reflect over K and then reflect over M. So you actually, it ends up being exactly the same for these two. You just got to change the number from twice 60 to twice 45. Down here, if we're going to talk about a translation, so this, I want two different notations. Sometimes I think it helps to plot the point. Excuse the
interruption. At this time, sophomores that receive an invitation for the award ceremony should proceed to the auditorium. Again, sophomores that did receive an invitation should proceed to the auditorium. There is a list of those students in an email from Angie Ingen. Thank you.
All right, so from P to P prime, in terms of the coordinate notation, I'm going to say x minus, how far left? From 1 to negative 8. I'm going to go left 9, and I'm not going to go up or down at all. So I could actually, shouldn't put 0, should put y. That's my coordinate form. Now my component form is the vector, the way we say don't go up or down, but just go left or right. I want to go left 9, so negative 9, and don't go up or down. That's where the 0 comes in. So this is your coordinate form, and this is your component form of the vector. So those are the two ways you can map a translation. Last thing is a rotation. The first thing you want to do is plot your points. So that's my P. Q is 4, negative 1. That's Q. And R is 2, 2. That's R. I'm going to go ahead and draw my triangle, and then I'm going to lock all this together, and we're going to see how you can actually turn your paper to help you do with your rotations. So what I'm going to do is, just like, whoa, where was that? 4, negative 1 is Q. These, I'm going to group them all together, and I'm going to now take this and rotate it. When it says 90 degrees, that means we want to rotate counterclockwise. So I'm going to go to the left counterclockwise, and I'm going to write down the coordinates of my new points. P prime would be at negative 3, positive 5. Q prime would be at 1, positive 4. And R prime would be at negative 2, 2. Now, if you remember your rule, if it's a 90-degree rotation, the rule is you take B and you move it over here. You change the sign, so it's negative B. A is the rule we use. If you want to just do the piece of paper, that works too. So that's my first thing I did was I did my rotation. I'm going to plot those points. Right here is my P prime. Q is right here. That's Q prime. And R prime is at negative 2, 2. That's R prime. So I'm going to redraw that triangle. Now what I need to do is reflect this triangle in the line y equals negative x, which is this slope of negative 1 line. If you remember your rule, you're going to say A to B maps to, you flip them and you change their sign, so negative B, negative A, which means P should be at, if this was negative 3, positive 5, it should be at negative 5, positive 3. Negative 5, positive 3 is right here, and you can actually confirm that by looking and say, oh yeah, that's equidistant from that line of reflection. That's P double prime. R prime is going to stay where he's at, so I'm just going to say that's the same thing since it's on the line of reflection. And Q double prime, if you flip it, it's going to be negative 4, negative 1, negative 4, negative 1's down here, and that's your Q double prime. That is also equidistant. So my triangle right here, I guess that should be solid, but that's okay. That's my final triangle is over here. The last thing is types of symmetry. So types of symmetry, let's see, if I mirror this guy across that line of reflection, that's line symmetry. I also have line symmetry here. I don't think you have any rotational symmetry, although it looks like you kind of want to say you do, but you don't in this problem. The last one, if you had rotational symmetry, sometimes we think of this like as the petals of a flower. If I rotated any multiple of how many petals there are, and there are 1, 2, 3, 4, 5 petals. So if I do 360 divided by 5, I get 72 degrees. Any multiple of 72 will give you your rotational symmetry. So 72, 144, everything all the way up to 360 and beyond, those are your rotational symmetries that you have. I don't think there's any line symmetry in this one.